Welcome to this webinar on modeling with CNOSSOS-EU. I hope you can all hear me. I'm Erwin Hartog van Banda, and I will be your presenter of today. I will go into the latest information on CNOSSOS-EU. The next planned webinars, I will introduce CNOSSOS-EU, the calculation method, and then I'll go into some issues not issues, but some features in modeling in Predictor on the source databases and the calculation settings. Looking at the latest information on CNOSSOS-EU, it is expected that next month a revision of the method will be sent to the noise expert group for review. The modifications in the review will be based on the REVM report from August 2019. In the REVM report, there were some recommendations of changing parts of the CNOSSOS-EU method and to make it more clear and to take out some errors. The intention is to have this updated CNOSSOS-EU method accepted by Brussels, in fact the EU, before the end of this year. Looking at the quality assurance, the latest version is still a draft from October 2019. It's unclear at the moment if this draft will be updated or even need to be updated, and in that case it will stay the same. Because in the latest version of the quality assurance, there are several recommendations of the REVM report already included. And as you all know, Predictor Lima is calculating conform this draft of October 2019. So we have to wait and see. Planned webinars. Well, today, Modeling with CNOSSOS-EU Part 1. I'll go into the introduction of the method, a little bit about quality assurance, mainly about source databases and METU settings. There's a lot to tell you about those parts of the method. Next month, 19th of May, I will go into Part 2, Modeling with CNOSSOS, and then I'll go into the receivers at facades, optimization settings, tilings, address points, number of exposed people, and dwellings. Then in June, I'll go into a new version of Predictor. We intend to release Predictor version 2020.2 with some new features and some cloud calculation support. Okay, the CNOSSOS-EU method. As we all know, it's a European calculation standard released or defined in May 2015, and it was published in July 2015. And the first mandatory use of this method is for the coming round of noise maps in 2022. It describes one propagation method for industry, road and rail, and a separate method for aircraft noise. Ground operations, however, for aircraft noise can be calculated with the industrial method. The aim of CNOSSOS is to calculate the long-term equivalent noise level for industry, road and rail in octaves from 63 to 8000 Hz. So you will not find the maximum noise level in CNOSSOS-EU, the LMAX. No, it only describes a method to calculate the long-term equivalent noise level. The air absorption is according to the ISO 9613.1, part 1. If you look at this part of the text of the CNOSSOS-EU method, in chapter 2.5.1, the scope and applicability of the method is described. And here it's described that there are two types of atmospheric conditions handled in the method. First, a downward reflection propagation, which has been called favorable, and a homogeneous atmospheric condition. So you've got two meteorological conditions in CNOSSOS, favorable and homogeneous. So you cannot calculate a side wind or an upwind meteorological condition. Only favorable and downwind situation and homogeneous. And in fact, in the calculation settings of Predictor, you can define how much percentage favorable there is in the day, evening, and night situation in 20-degree angle steps. All, of course, intended to calculate a long-term equivalent noise level. If you look at the road source model, CNOSSOS-EU defines 5 categories: light, medium, heavy, heavy, two-wheelers, and an open category. For all these categories, they have the same source height, 5 centimeters above the ground. The source model itself is quite complex. It depends on the rolling noise, propulsion noise, studded tires, acceleration, deceleration close to the crossing, crossing types, road surface, slope gradients. Those are the main aspects of the source model. I will come back on that later. If you look at the rail source model, complex source model depending on rolling noise, rail wheel roughness, impact noise, crossings, switches, squeal, traction noise, aerodynamic noise, etc. The source model for rail sources is 1/3 octave. However, for the propagation and calculation, full octaves are used. So the source model calculates some power levels in 1/3 octaves, but then you need to convert it, or of course in Predictor that's done automatically, to octaves because the propagation method is in octaves. The source height, the rail model uses 2 source heights, 0.5 meter and 4 meter above the rail track. And depending on what type of noise, a certain source height is used. For rolling noise, 0.5 meter, traction noise, both 0.5 and 4 meter, aerodynamic noise, 0.5 meter and 4 meter, the other types of noise on 0.5 meter. If you look at the Lima-Knossos method implementation in Predictor, it's the first method in Predictor that supports all source types in one model. So you have not only the industrial noise types, point source, line source, area source, moving source, emitting facade, and emitting roof and wind turbine, but also the road and the railway, all in one model. I will show you later on. By using groups, the results per source type can be shown. So you can put your roads in one group, railways in one group, and industrial sources in one group, and then you can show your noise contours or your results per group. So that's a very elegant way. It uses the advanced Lima dynamic source segmentation technique for the pathfinder. And yeah, that's a very elegant way and having a smooth way of calculation. Looking at the quality assurance, like I explained, Predictor Lima is defined on the draft of October 2019 that already contained several recommendations of the RIVM report from August 2019, and Predictor Lima was the first software to fulfill this draft. Okay, if you look at the calculation settings, you see that there's an option to select Methodological Correction for a certain location. I will come back on that later. Also, you see here the average temperature and the amount of a month per year that studded tires are used. So that's an overall calculation setting. First, let's go to the meteorological correction. This is how you define the meteorological condition for your calculation. You have to select a location. There are a number of default locations in Predictor, but you can also add your own location. And per location, you can define the percentage favorable per 20-degree angles. And these angles are wind directions. So it's in percentage favorable. And of course, homogeneous is the 100% minus favorable. So you can only define how much percentage of the day, evening, and night period it is favorable conditions. And then the other part of the 100% is considered to be homogeneous conditions. Like I said, per day, evening, and night, per wind direction in 20-degree angle. And wind direction means that a wind direction of 0 degree is a wind from the north, because the positive y axis in Predictor, the positive y coordinate is assumed to be the north direction, and positive x direction is assumed to be the east direction. So that means that the wind coming from 0 degree is a wind coming from the north, and a wind direction of 90 degree is a wind coming from east. These meteor conditions for the default regions are taken from the NMPB 96, and like I explained, new meteorological conditions can be added. Then source databases. In Predictor, there's a database for industrial noise, and that's in fact the Imagine Sound Power database. That's a comma-separated file located in the Predictor program folder. And then there are default XML road catalog files and XML rail catalog files. The road catalog file is located also in the Predictor program folder, and the rail catalog file is also located in the Predictor program folder. The XML format of these catalogs, of the road and rail catalogs, they have been defined by DGMR on behalf of the CNOSSOS-EU working group. So we have a document which I will send to you by email for download with the full definition describing how the XML format is defined. Okay, I will now switch and show you where the catalogs are located. I will now switch to the Predictor program folder. This is, for instance, the Predictor program folder for version 2020.1. In this folder, next to the calculation files of, for instance, predictor.exe, you also see the default catalog files for industry, for rail, one for the track definitions and one for the vehicle definitions for rail, and also for the road for the vehicles, and for the services. And if I open, for instance, the road parameters, open with Notepad, for instance, then you see it is an XML format. It's text, you can read it, but the format of the text is an XML format. And then, of course, within the XML format, there are how do you call it, obligations on how to use the text. So here you see light vehicles definition, light truck definition, heavy truck definition, light mopeds, etc. And there's also an open category which you can add yourself. Of course, the idea is that every member state creates its own XML file, because all the parameters here and all the coefficients to calculate the sound power level are also in this XML file. And of course, every member state might have its own sound power levels for the categories, its own categories, its own vehicles. So every member state will have to change and adapt this XML format and then make it available for those who want to calculate the noise maps in that specific region. Okay, let me close down this one. The road rail. So when you create a new model in Predictor, these default catalogs in the Predictor program file, folder are imported in the model. And you can view them in the model, I will show you. And you can also replace this default catalog in your model by using import options and also export using export options. I will show you. Let me just see. Yeah. Okay, now I'll switch to Predictor to show how it works in Predictor. So this is a Lima CNOSSOS model. I go to the calculation settings, go to the method. Here you see this meteorological conditions. If I click on the button here, you see all the default locations, but you can also add your own locations with the percentage of favorable divided over the periods and over the wind directions. Then here you see two buttons, road catalog and rail catalog. If If you click on road catalog, you can view the default road source catalog that's in the Predictor program. No, not necessarily in the Predictor program folder, but this is the catalog that you use in this model, because you can import another catalog in this specific model. So these catalogs could be kept in a total different folder. So you can import your national model, your national catalog here. This is for the road parameters. This is for the road services. Similar for the rail catalog. If you click on the button rail catalog, you see the rail vehicles and the rail track definitions. And here you can import a new track definition or export the track definition, the XML file, to another location for reuse in another model, another predictor model, for instance. So it's what you can call an open source model. You can change the model to your liking. And once you have changed it, so I double click on a railway, and here I see the properties of the railway, the coordinates, and here the type of train, the speed, the flow, etc. This is the list coming from the XML file. So if you change the XML file, you also will have a different list of trains. Here you select the train type, you select the type of speed, if it's constant, acceleration, deceleration, or idling. If you select idling, you can also enter the number of minutes per hour that the train is idling. Of course, if it's not idling, if it's a constant speed, you cannot enter the idling time. So the flow, the hourly flow per period, and the speed in the day period, the same for the evening and the same for the night. Then you select track definition, track transfer, structure, rail roughness, impact noise, bridge, curve radius, and based on these settings, these selections, and the XML file, Predictor calculates the sound power level for the day, evening, and night period. You can also check exactly how this sound power level is calculated. If you click on the button Details, there's a full list of, again, the XML file for the vehicles and for the tracks that's being used in the model. Then your selected input for this rail. You have selected category number 9 with a constant speed, 10 per hour and 70 kilometers per hour. And based on all these settings, Predictor calculates the sound power level. And so here you see exactly, for instance, this 73.2 dBA. If you go to the details, 72.3 dBA, the final, the 8000 Hertz. These are all the frequencies, the 73.2 dBA total. And this is all the intermediate results for calculating the sound power level. So it gives you a full insight in the way your sound power level is calculated. So it's really an open source source model. The same applies for road. If I double click on a road, here you see the categories, and here you can key in the traffic flow, the speed, etc. You see that the source height, you cannot change the source height, that's always 5 centimeters. The slope, the junction type, and the distance to the junction. Say there's no junction, the distance can be 0. Then the emission, the sound power level per meter based on your settings. And again, for a road, here's your detail button. And you can check again how these result based on your input, the slope, your selected road surface, how many months a year you have studded tires, and then the fraction of studded tires, because I have not shown you this, but in the properties, there's also a fraction of studded tires here for this category. So based on your input, Predictor calculates the sound power level of this specific road. Okay, now coming back on the group mechanism, if you go to the group manager, here you see that you can use groups to separate the industrial sources with the railway sources and with the road sources. Wait, because there's, yeah. So here you see the industrial sources. There's only one point source, there's only one railway, and there are many roads in this model. So that's an elegant way of dividing your sources over groups. Let me see, what did I want to show you more? Catalogs, edit, windows, calculation settings. No, I've shown you those. Okay, so that means I've shown you the vehicles, the road catalog, the XML format for the vehicles. Sorry, for the vehicles, for roads, for the services, for the roads, the rail catalog for the vehicles, the rail catalog for the tracks. Then for point sources, yes, point sources. If you click on the button here for a point source, you can select a sound power level from the Imagine sound power database. Go back to Predictor, double click on the source. Here with the emission, you can enter it either dBA, dBc, dBc, weighted. But if you click on this button, the database opens. We've got not only the Imagine sound power level database, but also the BS5228 database is also included. But let me scroll down to where the Imagine source database starts. That's somewhere here, I think. Lifting truck. Yeah, here it is. Okay. Oops. I did something wrong. Yep. This is where the sound power database from Imagine starts. So it starts with an air cooler, etc. So here you've got all the sound power levels and you can select out of this list. So if you want to have it an auxiliary unit, you simply click here, you select it, and then your sound power level is entered in your fields. Okay, switch back to my presentation. So this is the sound power database for point sources. Well, this is the road property form. And like I explained, slope, crossing, junction type, the traffic flow per period for the day, evening, etc. And then based on these settings, the emission, the sound power level is calculated. Similar effect for the railway. You select the type, you enter the type of railway, kind of vehicle, then the type of track, and then the emission is calculated.